Hi all, I am going to present the ductile to brittle transition temperature, which is commonly known as Dbtt, and its industrial examples. Okay, let us move to the topic. What is Dbtt? Dbtt is nothing but the temperature below which a material changes its behavior from ductile to brittle. It is the Dbtt curve. In this curve, there is in the upper shelf there is a ductile behavior, and then in the lower shelf there is a brittle behavior, and in the x-axis is the temperature, and in y-axis is the energy absorbed. Okay, which means above the Dbtt, the material undergoes plastic deformation before fracture. It can absorb more energy and then gives warning before the failure. Below the Dbtt, the material behaves brittle and then the fracture occurs suddenly without any deformation. The Dbtt can usually be determined with the help of Charpy impact test, and then it is a common in BCC metals like ferrite steels. Importance of Dbtt in industry. The first one is it can prevent the sudden brittle fracture. Okay, I would like to briefly mention a historical example which is related to the brittle fracture. This event we all know that the RMS Titanic failure. The Titanic struck on the iceberg in the North Atlantic Ocean when the water temperature was close to 0 degrees Celsius. At such temperature, the steel used in the ship hulls behaved in a brittle manner. Okay, the ship hulls behaved in brittle manner instead of deforming. So the ship fractured and then the crack propagates rapidly. So what is the reason behind the failure means the material had low impact toughness at the low temperature. Okay, and then second one is it ensures the safety in the cold environment. The temperature may fall below the transition temperature. Then third one is it helps in selecting suitable materials. The engineers can select suitable materials based on the conditions, and then it can reduce a risk of catastrophic failures. Okay, finally, understanding the Dbtt, it can reduces the risk of unexpected structural failures. Okay, now it is the industrial example, pressure vessels and then pipelines. Okay, in the pressure vessels and pipelines, especially those used in oil and then gas industries. Okay, they used in oil and then gas industry. Carbon steels are commonly used. Okay, carbon steels are commonly used. In the cold regions, the operating temperature may approach or fall below the Dbtt. If this happens, the material may fracture suddenly under the internal fracture. Due to the internal pressure, there is a sudden fracture may occur. Okay, so we can use the materials with the low Dbtt. Okay, the next example is bridges and then structural steels. Okay, the bridges and structural components are exposed to environmental temperature, including the winter conditions. If the steel used in these constructions has a high Dbtt, it may become brittle and during cold weather. Okay, during the winter seasons, if we can use the high Dbtt steels, it may occur failure at sudden. So we can use only the low Dbtt steel was used. It can prevent cracking under load. Okay, if the bridge is like this due to the heavy loadings. Okay, due to the vehicles can move above this upper load, so it can lead to fracture. Okay, the vehicles or wind fracture, the brittle cracking may occur. The another example is railway wheels and then tracks. Railway wheels and tracks are made from the carbon and then manganese steel. Carbon and then manganese steel. During the cold nights, we can see that the temperature of rails may drop significantly. If the temperature falls below the Dbtt, the rails can become brittle and may crack under dynamic loads from trains. So the Dbtt testing prevents the rail fracture. Offshore and then marine structures. The structures are subjected to wave impact loading and fluctuating stresses. If the material becomes brittle at low temperature, the crack and propagates rapidly. So, in this case also, we can use the low Dbtt steels are used. Okay. Next one is cryogenic storage tanks. The LNG storage, such as the temperatures can reach as low minus 162 degrees Celsius. Minus 162 degree Celsius. At such low temperature, many steels would become extremely brittle. Okay, in this temperature, most of the materials can brittle, and then therefore the materials like austenitic steels are preferred because they do not exhibit a sharp ductile to brittle transition. Next one is automotive applications. In the automotive industry, the components such as the suspension and then steering facts may experience the impact loading. Okay. During the cold conditions, these components may operate near the Dbtt. In the cold conditions, it can operate near the Dbtt. If the material becomes brittle, sudden fracture can occur during impact, such as hitting a pathway. Okay, finally, comes to the conclusion. Okay, it is a critical for material selection. Dbtt is critical for material selection, and then understanding the Dbtt helps to prevent the brittle fracture and ensures the structural safety. Therefore, the proper testing and the selection are essential to avoid the failures. Okay. Thank you.